Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we would talk about protecting the management plane. Now as you know, management plane is extremely important to protect because along with the control plane, if let's say there was a DOS attack using on your data plane, the control plane and the management plane could get affected. And if I cannot access my network, if I cannot go and access the device, there's no way I would be able to control the attack. So basically, management plane is used to access, configure, and manage a device or a group of devices or the network which is running on those devices. There are different ways of managing or accessing those devices, which we would talk about in the next slide. But like I said, controlling the attack is extremely important, and that can only be done with the management plane. When configuring the security of a network, it is critical that the management plane is basically protected because you would not be able to stabilize or recover the network if the control plane is affected, which basically affects even the management plane. Because if I cannot access the network, or if my control plane is dead, if my routing protocol is gone, then I may not be able to access the network or the router, and I may not be able to contain the attack. So administrators must always take precautions to protect the management plane. Now, these are the following list of protocols which are basically used by the management plane, which you must think about protecting. The first one is going to be SNMP. So you must think about protecting the SNMP because that's one of the protocols used for managing the devices. The next one is going to be Telnet. Now again, Telnet is something that it's not recommended. You should kind of disable Telnet. But if you are using Telnet to access your devices, then you must think about what can I do to protect my Telnet connection to my router. The next one that you can think of from management protocol perspective would be SSH. Again, you should have strong passwords for your SSH logins. You must think about protecting your SFTP and FTP. Again, these are services which are not enabled by default, but if you do enable them, then you should think about protecting them as well. We have TFTP to manage your images, so you should protect that as well. Then your SCP, which is Secure Copy Protocol, you should also protect that. Obviously, you should think about protecting your TACACS and Radius because if that goes down and you don't have a backup method for authentication, you basically lose access to your management plane and you may not be able to connect to your devices. So protecting your TACACS and Radius server, which could be maybe an ACS server or an Open Radius or maybe ICE, in that case, you will not basically be able to access your devices. So that becomes extremely important to protect all these protocols that we have. Besides that, we also have NetFlow and NTP. So NetFlow was basically when it can be used by data plane also. So it is used to gather statistics about what's happening on my interfaces or my devices. NTP, extremely critical. Now you may think why NTP is critical, why do I need to protect my time being synced on all the routers? Now imagine if your NTP server goes down, what's going to happen? Normally in production you would have all devices using certificates, and certificate relies on time to be correct. If your time is not correct, your certificate would be invalid, which means you would not have access to your management plane or access to devices. Because if you are not doing password-based or username password-based authentication and you are doing cert-based authentication, then NTP plays a critical role there. Lastly, you do want access to your syslog server because you want to look at the logs to basically analyze or to create a strategy to define how I would protect my data, which is how do I protect my network or my routers, which is under attack. So the first thing, let's talk about how do I protect my passwords. Now, obviously, as you know, password is basically for authentication, right? When you access the devices, the router is going to challenge you back with asking you for a password. Typically, you would not want to have just password as an authentication, and you would not want it to be done locally, you would want a AAA server. But let's say if you were not using any AAA server, you don't have a local username password, but you were just using password for authentication, which is not recommended. But still, that's one step of protection, at least one step of protection rather than not having a password. So password could be in clear text or it could be encrypted. So you should not use the clear text. In fact, you should protect your password also by defining it with the secret keyword. So you create a username, maybe you create a local username, or you go inside your Line console or Line VTY for remote logins and define a password there. So that password can be encrypted. So you can do a service password encryption to basically encrypt the password even in your running config. So you don't want somebody looking over your back and looking at your password. The next thing that you should do to protect your control plane is basically, like I said, don't just use a password, use defined usernames. So there are various levels of usernames that you can define and give them permissions. So you should always have a username password being prompted when you connect to a device, whether it's a local access through the console or it is access through a remote login, maybe through Telnet or SSH or maybe even HTTPS. So if you try and access the router, it should prompt you for a username password. And that could be done locally by locally creating a username password, like a local login, or you could do it through an application or a Radius server, which could be ICE, as far as Cisco is concerned. I mean, Cisco does have an ACS server, but that's going away. But Cisco is mainly moving towards ICE now. So if you look at the XR routers, they basically provide you with built-in multiple levels of permissions, which are basically called as user groups. So when you create a user, you can assign the user to a group. Each group has various levels of permissions. So let me in fact show you on the router. I would access my XR1 router and maybe show you creating a user, and I'll show you the list of built-in groups available, which you can assign that group to the user. Depending on which group you assign to the user, that permission you get. You can still create your own custom group and define your permissions, but XR routers give you pre-built-in groups, which you can assign to a user. And one thing that you should know that you must create a root system account. The root system is something like in iOS XE, we have like a privilege 15 user, which has full access. So you at least need the root system account to be created. And from there, I can maybe create more users, give them various permissions through the user group. So let's go to our router. And here, if I look at let me go back to my router. So here, if I go back and create a user account, maybe I go and say user test. And if you see inside this, I can specify the password, I can specify the secret password. Don't try and use the password command because that's clear text. Try and use secret because that's more secure. But every user needs to be assigned to a group. And if I look at the group options that I have here, group, and do a question mark, I have multiple built-in groups available, which you can see here. If you look at the Cisco support, it's basically used for debugging and troubleshooting features. So if you want to give some user just access to debugs, then you would basically go and assign the user to Cisco support. We also have maintenance, which basically can be used for maybe upgrades when the administrator wants to do maybe a system upgrade or maybe upgrade the image. That's when you can probably use this one. We have the net admin, which basically gives the user configuration tasks, such as maybe building a routing protocol. We have the operator, which can do day-to-day monitoring he basically has limited rights, but he can still do monitoring. We have the root system, which is basically full access, privilege 15. We have the system admin, which basically gives him access to store core dumps or maybe set up NTP. And we also have the service admin, which basically gives him access to creating service administrative tasks. So these are built-in groups available, but if you want, you can even customize your own, you can create your own and assign that to a user. So here is an example where I create a user account, and this user account has been defined with a password. Again, try and not use the password keyword, try and use secret because that's more secure. And then this user has been assigned to the group root system, which means he has something like privilege 15, full access. The next thing that you should do would be basically disable unused services. Now, you don't want unnecessary services running on the router. You don't want that. So if there are services which are not being used by your management plane or even for your business purposes, if you're not using that, you should probably disable unused services. Some of the unused services that you should disable, if it's not being used by your business, would be TCP and UDP small services. They basically include echo, discard, daytime messages. You should basically disable all of these. You should also disable HTTP, maybe keep HTTPS on if you want to access the router remotely. Try and use HTTPS, not HTTP, so maybe you disable HTTP because a lot of information an attacker could pull from just HTTP. You should also disable CDP because a lot of information can be, again, gained from CDP information. Most Cisco devices send or have CDP enabled by default, unless it's a firewall. For example, an ASA firewall does not have CDP, but if it's a Cisco switch or a router, they basically have CDP enabled by default. So you don't want CDP to be enabled because from there, I would at least get information about what's his IP address, maybe what device he's running, which port he's connected to. I can get all of that information from CDP. You should disable SNMP if you're not using SNMP on the device, which then you should disable that. TFTP should be disabled because you don't want somebody connecting to you and maybe downloading stuff from your router or maybe configuring your device as a TFTP server to maybe send something to your device. So you should disable TFTP also. And finally, DHCP should be disabled on your routers. These are just the basic list which Cisco recommends that you should disable if you're not using them. But you could also disable a lot more services that you don't need if they are running on your router. So here is an example of disabling TCP and UDP small servers. So the command is no service IPv4 or IPv6, TCP small servers, UDP small servers. To disable TFTP, the command is pretty straightforward, no TFTP IPv4 server and no TFTP IPv6 server. To disable DHCP services, no DHCP IPv4 or no DHCP IPv6. And again, to disable HTTP, the command is no HTTP server. If you look at iOS XE, the command was no IP HTTP server. And again, CDP is enabled by default. The command to enable CDP is CDP run if you're doing it globally, or if you're basically disabling it on the interface, the command is no CDP. But, or if you're enabling it, it's CDP enable on the interface. But if you do want to disable that, you can do it globally or under the interface. The command is no CDP globally, or under the interface, you would say no CDP again. And to disable SNMP, the command is pretty straightforward, no SNMP server. The next thing that you should think about from protecting the management plane would be to set exec timeouts. A lot of times, it's something really simple, but a lot of times administrators forget about that. If you don't set exec timeout, what's going to happen? Let's say if I was working on the console, doing something, configuring something, and maybe I went to the bathroom. What's going to happen? If my session was connected, anybody could use that session, right? Somebody could sit on my desk and maybe configure something. So you should configure exec timeout so that your VDY, your console access, your auxiliary access basically gets timed out, or you get logged off if you're idle for a certain time. Again, Cisco's recommendation is maybe, okay, keep it like 10 minutes. that if you're idle for 10 minutes, it will disconnect your session. However, if you set the value as 0, you would never time out. To issue the exec timeout command or to set the exec timeout, the command is going to be line. You go under the line, whether it's your console or your VTY or your auxiliary or even line default, which basically applies to everything. So if I go to my line console and I give the command line console exec timeout and I set a value of 00, which basically means that my session would never time out even if I'm idle for 1 hour or 5 hours. It will never time out. Something that you should not do, you should always set the timers to maybe 10 minutes or 5 minutes. If you're idle, it'll disconnect you. To remove the exec timeout, the command is no line console exec timeout. Another way of protecting your management plane is going to be by using a simple access list. As you know, inside my line control or my line console, line VTY, line auxiliary, I can always assign an access list. I want to control who can access my device. I don't want that, okay, if somebody knows my username password, if somebody gets that by whatever reason, I don't want him to still be able to access. He should be able to access only from a certain network, which is normally a separate network, or maybe from the administrator's PC. So I can control who can connect to my device by using an access list and applying that access list to my console. So this basically protects not from any attacker, because now I'm controlling which network or which host can access my device, even if he knows my username password. So here's an example of how you would protect your management plane by configuring an access list and applying this access list to your interface, your management interface, or you could apply this to your console. So usually you would do both. So I would control my telnet or SSH by applying an access list to my console, and I would also apply an access list to my interface, to my management interface, to basically define what traffic can come in destined to the device and what traffic is allowed to go or transit that device. So here, if you look at this example, I am permitting routing protocols, I am permitting BGP, I am permitting BGP request and reply, I am also maybe permitting SSH, maybe network management servers, I'm permitting that, and denying all access to my device, and permitting all other traffic, which means I have to explicitly permit transit traffic. So assumingly, let's say if I was using my management interface for management and data, something like in-band. So if my one common interface was being used for management and for data, something which is not recommended. You should keep your management out of band, like separate. But let's assume that we were using the same interface for management and for transit data traffic. In that case, you would have to say, okay, permit these list of management protocols destined to my device, deny all traffic destined to my device, and then permit all traffic which transits the device. So you can probably define that with an access list. The next way of controlling or protecting your management plane would be through the MPP feature, which is Management Plane Protection feature. Now, this is a built-in feature which iOS XR has, which basically provides capability to restrict access to the device. Now, there are 3 ways to do this. There are 3 different options which are available in MPP feature. One is I enable it as an in-band management interface. The problem with in-band, which is not recommended, is that it will process management traffic. It will also process data plane traffic, which means my traffic is flowing for data plane also from that interface. Now, what's the problem in that? Imagine if I have a DOS attack. What's going to happen? My data plane is being attacked, which is going to affect my control plane, which is going to affect my management plane, which means I would lose access to the device. So something that you don't want is in-band unless you have no other choice, but something that you should avoid, which is in-band management interface. Because it processes both data plane and your management plane. The next one is out of band. In out of band, it will only process traffic which is destined to the device for management traffic. There is no data plane traffic, which means your customer's traffic would never forward from this interface. Basically, it's a management-only interface. This is something that you should do out-of-band management interface. You don't want it to be in-band. So any attack on my data plane interfaces would not affect my management plane interface because that interface is separate. Unless obviously the router is under tremendous pressure, the CPU is really high, and we lose access to the device. But you have a better chance if you have an out of band because you still may be able to connect to the device from a remote location or even console. But if you use in-band, you basically have no possibility of connecting to the router because your data plane will affect your management plane directly. We have another choice, which is out-of-band interfaces. This is similar to out-of-band interface. The only difference is that you have multiple interfaces for management, and it only processes management traffic, no data plane, no customer traffic. However, between two interfaces, between two out-of-band interfaces, it will process data plane traffic. So maybe I have multiple interfaces defined as management only, but between those management only, it can still process data plane traffic. So 3 options available to protect you from attacks by you having in-band management, outband interface, or even outband interfaces. Let's see how do we configure this. You basically go to your control plane, you go to your router, your XR routers, go under control plane, and go inside the management plane, and we define in-band or out-of-band. And define which interface is in-band. So we define the interface. We allow whether we want SSH to be able to connect to this management plane interface and define which IP address can also connect. And we also maybe allow HTTPS if you want HTTPS connection to this interface. This interface is going to process management traffic from via SSH or HTTPS from a certain IP or a subnet, which is 10.0.1.0. It will also process data plane traffic. Then we have an out-of-band interface configuration. So if I have out-of-band, I would again go to control plane, management plane inside that, and define out-of-band. Define the interface which is going to be used for out-of-band. And then finally define how will I connect to my management interface, which is going to be through Telnet or SSH, and I can define also which IP address can connect to this interface, IP address or a subnet. Then also we want to protect our SNMP. So XR routers can be used to secure your SNMP by restricting interfaces that is basically going to connect to your management plane. So interfaces which are basically terminating SNMP messages can be restricted by configuring the control plane, going back inside the management plane, defining it in-band, and then finally defining the interface which will allow processing of SNMP packets through a specific IP, from a specific IP or a specific subnet. So similar to how we would enable Telnet or SSH on the control plane inside the management plane, when I define in-band or out-of-band, I can define that, okay, I would still allow, besides HTTP and besides HTTPS and SSH and Telnet, I would still allow maybe SNMP messages to come in on that interface. And again, from a certain IP or a subnet. The next is protecting the telnet. If you remember, I told you earlier that one way of connecting to a router remotely is via telnet. Telnet is something that you should not use. I mean, you could still use it if you were out of band. But if you're in band, something that you should never ever enable because telnet is clear text. So by default, XR routers has telnet disabled. But if you do enable it, then things that you should do to protect your management plane, if you are using telnet for some reason, then you should have your management plane as out of band first of all. And then things that you can do to protect is maybe restrict your telnet by using ACL. If you remember, I told you earlier that under my line console, I could go and attach an access list which says that I would only allow Telnet from this IP, which is the administrator's, maybe his laptop or his specific PC. So if you're doing Telnet, you should restrict with an access list. You can also restrict the maximum amount of connections. So, because by default it's going to be unlimited, right? I could do 1,000 Telnet connections to my router. So you can restrict that also by defining the maximum amount of sessions at any given point of time to my router. 2 or maybe a low value, maybe 2 or 3, but don't give it too high. And the third way would be to basically limit the traffic rate through Telnet. So I don't want somebody connecting through Telnet. Let's say if my username password was compromised, or maybe my password was in clear text, I never used secret, I never had an access list, and somebody gains access to this. I don't want him running some scripts which basically does things on my router. So I want to rate limit that, basically police the amount of traffic which is going to be used through that Telnet session. That can also be done by using the local packet transport services, which is a built-in feature available in XR routers. Here is the command to basically enable Telnet for a specific IP, and also defining the number of sessions that is allowed through Telnet. We can also use the local packet transport services, which is LPTS feature, which can be used to do rate limiting for that Telnet session. So here I'm basically saying that flow Telnet default rate is 200, and then I define that the known rate is 200. Basically what we're doing is just policing the traffic rate for Telnet service. The next thing that you can think about from protecting the control plane is protecting your console, VTY sessions, or virtual remote sessions basically. You should always protect that, because you don't want somebody physically going to your device. Sometimes it may not be, you may not have access to the data center room, but let's say if somebody did have access, you don't want somebody just going to your device and putting a console and connecting. You should protect your console, you should protect your VTY sessions. So that's going to be done by many ways. You can have line console 0, go inside that and set the secret password, define access list, also maybe define authentication, not by using a local method. Maybe local could be a backup in case if the TACACS radius goes down, but you should always have your console and VTY pointing to a radius server which could have authentication done. If you're using TACACS, you could even do command authorization. So if he types something, if he does config T, it goes back to ICE and does a command authorization. Does he have access to, does he have the permission to basically run that command? So I could do user authentication through ICE. I could do a basic authorization, does he have the permission to log in? And once he logs in, then does he have access to the commands that he is executing? So you should probably restrict all of these on your console by using a radius or a TACACS server. You could still do it with local database. So maybe I could do a username password authentication through the local database, and maybe do authorization, like command authorization by creating privilege exec levels, and doing local-based authentication and authorization. You could still do that, but it's not scalable. The next way, or the last way of maybe not last but not the least, would be warning banners. Now you may think, why do I need a warning banner on a router? It's not going to protect me, right? But a lot of times in many different states or countries, you cannot prosecute an attacker if the attacker was not given a warning sign saying, hey, you are not authorized to enter this network or this router, to connect to this router. If you are connecting, disconnect now. So if there's no warning banner, you may not be able to prosecute that attacker. So you should have a warning banner. Again, that can be done with banner message of the day by setting up, maybe this is a you are not allowed to access this network or access this device. This is restricted to access. It's really up to you what banner you want, but you should have a banner. So coming back to management plane, now as you can see, that management plane is extremely critical to protect, because without the management plane, I would not be able to connect to my devices which are under attack and protect that device. I hope this video was informative to you, and thank you for viewing.